Good morning everyone. Today we will talk about the congruency in geometry and what is the meaning of congruency and how to prove that or say that two polygons are congruent. Here the symbol of the congruency, we can make it as equal sign like this and put another one over it. Here the symbol of the congruency. Okay, what is the meaning of the congruency? It means two polygons are congruent or identical, like each other, have the same sides and the same angles. So here the two polygons are congruent if their corresponding sides are equal in length. Okay, sides equal in length, and also their corresponding angles are equal in measure. So again, their corresponding sides are equal in length. Each side in each polygon are equal to the other sides in the other polygon, and their corresponding angles are equal in measure. So again, the two polygons are congruent if their corresponding sides equal in length and corresponding angles are equal in measure. Can I say that their corresponding sides are equal in length only? No, because it's needed to say that their corresponding angles are equal in measure too. So here we have two conditions for the polygons are congruent, their corresponding sides equal in length and corresponding angles are equal in measure. Here, as we see, for example, here we have two polygons like A, B, C, D, E and X, Y, Z, L, M. Take care when we read or when we write here the congruency between the two polygons, we must write it in order, like each other exactly. Like here at the first one, here when we say A, B, C, D, E. Okay, at the order A, B, C, D, E. That's mean what? That's mean here A, B, C, D in order. The big one, A, B. That's mean it's congruent to or equal in length as X, Y. Look at this line, here we have 3 marks. And here also we have another 3 marks. That's mean A, B equal to X, Y. So here I will start order from A, then B, then C, D, E. So here the same order. We must start from X, Y, then take the same term X, Y, Z, L, M. And here we will put here the congruent sign and write X, Y, Z, L, M. Okay, here we have A, B, C, D congruent to X, Y, Z, L, M. That's mean what? That's mean AB equal to X, Y. And the first one, AB equal to X, Y. And also angle A equal to measure of angle X. Again, AB equal to XY line center in the length. And the measure of angle A, this angle in the big one, equal to the measure of angle X. For example, if we have the angle A equal 90 degree, so also measure of angle X equal 90 degree, the same. BC with the blue line equal to YZ, they are equal in length. For example, if I have BC equal 4 cm, so also YZ equal 4 cm, the same. And the measure of angle B, the blue angle, equal to the measure of angle Y, the blue angle down and the blue angle up. So here these two angles are equal in measure. CD equal to ZL, with the vertical one, ZL equal to CD. The measure of angle C equal to the measure of angle Z. DE equal to LM, and the measure of angle D equal to measure of angle L. The red one. Here EA equal to MX, here the green one, and also measure of angle E equal to measure of angle M. Then the polygon ABCD is congruent to the polygon XYZLM as we wrote it up, ABCD, congruent to XYZLM. So again, here it's needed to write the corresponding sides and angles. It's not enough to say that the sides are equal in length. We must write the sides equal in length and also angles are equal in measure, and we must write it in order. Okay, here we have special cases for the congruence between the polygons. For the first one, if we have two squares, I know that the square, all of the side lengths are equal in length. All side lengths like AB, BC, CD, and BA, all of them are equal in length. For example, if I say that AB equal 5, so here BC also equal 5, and CD equal 5, AB equal 5. Here next one is the L. If I say just one side, x, y equal 5. So all of the sides of the square x, y is the L, all of them also equal 5. So here I can say that ABCD congruent to x, y, z, L. If I have just one side in one square of each of them equal to the other side in the other square, so the two squares are congruent. Here I said to you, the two squares are congruent F. Come in the exam as a complete. I said for you, two squares are congruent F. And then we will complete if the side length of one of them, just one side, equal to the side length of the other. For example, we say the square ABCD congruent to the square XYZ is just one side, AB equal to XY or BC equal to YZ or any side of them equal to the other side of the other side. Number 2, here we have the two rectangles are congruent F. Here I have two rectangles A, B, C, D, and here X, Y, Z, L. Here these two rectangles, I can say that these two rectangles are congruent F. Two sides. What is the meaning of these two sides? The length and width. And I can say that two dimensions. So here I have two words for it, length or width, and the two dimensions. Okay? Here if I have BC, the width of the first rectangle, and the length AB for the first one, equal to the length of the first one, XY, and the width of the second one, YZ, are equal to. So here I have two rectangles are congruent F. The answer will be the length of one of them equal to the length of the other, and the width of one of them equal to the width in the other. In other words, here we have two rectangles are congruent F. The two dimensions, what is the meaning of two dimensions? Length and width of one of them equal to the two dimensions of the other. Come in the exam as a complete. He will write for you two rectangles are congruent F dots, and he will complete the two dimensions of one of them equal to the two dimensions of the other. Okay? He will say that the rectangles ABCD and XYZ are congruent if AB equal to XY, BC equal to YZ. Number 3 here, equality and corresponding sides of two triangles. How can I say that two triangles are congruent? Here is enough to be congruent triangles. That's because equality of corresponding sides of two triangles leads to equality in their corresponding angles. What is the meaning of this one? Here it says for you, if AB equal to XY, Z1 equal to CB, and XZ equal to AC. That's mean if the two triangles are congruent. Why? Because here the sides, if the sides are congruent, leads to the angles will be congruent also. Just condition only in triangle. Here this angle equal to this angle, and this angle equal to this angle. Okay, so here only in triangle it's not necessary to be the sides are equal and the angles are equal. Okay, it's just enough to be the corresponding sides of two triangles, all of them are equal to. Okay. Here I have the two polygons. If two opposite figures are congruent, let's complete. First, we must write the key. We must write the key. We must write which one of them equal to what in the other polygon. First, I must write here the name of the polygon. In the first one, I will name it as NBO. NBO. Congruent to what? Take care, we say we must write here the polygon in order. We start from N and we take the lower side. So here is the same with the other polygon. I will start from Z and take the wrong sign. I will start Z, D, X, Y in the same order for the first one. It's named Z, T, X, Y in the same order. So again you have N, B, O congruent to Z, D, X, Y in the same order. Okay, let's complete. M equal to, don't look to the figures, don't look to the figures, look at the key R. You wrote here the key to solve from that. He said for you N, number 2 then number 1. So in the other one I will take number 2 and number 1. So M equal to TZ, number 2 then number 1. So here M one side equal to Z one side. But we get it from the key. Again, N O equal here N number 1 and O number 4. So I will take number 1 from the other one and number 4. So I will take Z Y. OB equal to here O number 4 and B number 3. I will take 4 and 3 from the other one. Here 4 and 3 it will be Y X. BM, here B number 3 and M number 2, I will take from the other key with 3 and number 2, XT in the same order. Measure of angle M, measure of the second one equal to the measure of the second one and the other one, where it will be measure of angle T. Okay, and the measure of angle M, measure of the first one equal to the measure of the first one and the other one. It will be a measure of angle Z. Okay, measure of angle O, measure of the first one equal to the measure of the first one, measure of angle Y. And the last question here I have measure of angle B equal to measure of angle X, because you be number 3 and also the other one in the key X is the third one, so it will be measure of angle X. Okay, let's take another example. Here I have two triangles. Okay, here in these two triangles I have numbers. I have this angle B. Look, this is more square, means that this angle equal 90 degrees. Is it right? Okay, let's try to read the key. I have the key. Triangle ABC congruent to triangle XYZ. That's mean what? That's mean measure of angle A equal to measure of angle X. Measure of angle A equal to measure of angle X. X here 30. So here measure of angle A will be also 30. Measure of angle B, number 2 equal to measure of angle Z. Number 2 is the other one. Measure of angle B 90. Also measure of angle Z will be 90. Measure of angle C number 3 equal to measure of angle Y number 3. Okay, here number C equal to Y, and I don't have the third angle in each of two triangles. How can I get the third angle? Who can remember? I will make 180 minus open bracket 90 plus 30. So how can I get the third angle of any triangle? 180 minus open bracket 90 plus 30. With the plus of 90 and the 30 equal 120. And then 180 minus 120, you're 0, you're 6, you're 0 cancel. So the third angle will be 60 degrees. So angle C equal to angle Y equals 60 degrees. So here when you ask you about measure of angles is equal to degree, okay. Here in this one, he asked about the degree. He asked about the degree, he need number. But in the previous one, he asked about measure of angle M equal to measure of angle Y, because he didn't put here the degree mark. So here measure of angle Z, measure of angle Z equal what? Equal 90. Measure of angle Y equal what? Equal 60. I complete my question before I solve. Measure of angle A equal 30. Measure of angle C equal 6. I complete all of the points. Okay, let's solve. Next one. Here in the opposite figure I have if triangle ABC congruent congruent to x, z, y. Here is the key. Here 1, 2, 3. Here 1, 2, 3. Okay, let's complete. Here x, z, the x, z, number 1 and number 2. Equal to AB, number 1, number 2. Here x, z, x, z, x, z. Here x, z. Equal to AB, AB. Equal how many centimeter? It equal 4, so here equal 4. So here when you ask you about x, z equal how many centimeter? Equal 4, like AB. X, y equal how many centimeter? X, y. X, y number 1 and number 3. Equal to AC. AC equal what? Equal also 3. So here XY equal 3 centimeter. Then find the perimeter of the triangle ABC. How can I get the perimeter? The sum of all outside lengths of the figure, of any figure. So again, how can I get the perimeter of any figure? The sum of the outside lengths of the figure. Okay, here how can I get the perimeter of ABC? How can I get the perimeter of this one? I must make plus with 4, 3, and this side. Okay, the side is missing. Here CD. CD number 2 and number 3. So from the other triangle, number 2 and number 3, ZY. ZY equal what? Equal 6. So also this side equals 6. So here to get the perimeter, we will make 3 plus 4 plus 6 equal 13 centimeter. So again, to get the perimeter, I must complete here all the information around the triangle from the other triangle. You must complete it. Here I have triangle ABC congruent to XYZ. Here I have AB equal to XZ. So here XZ also equal 4. BC equal to ZY. BC equal to ZY, so BC also equal 6. AC equal to XY. AC equal 3, so also XY equal 3. So here I have all of the information. How can I get the perimeter? I will make plus for all of the sides. 3 plus 4 plus 6 equal 13. Okay, here the symmetrical figures and line of symmetry. Here we say that a figure has a line of symmetry or an axis of symmetry. You will have another name for a line of symmetry. It's called the axis of symmetry. What is the meaning of axis of symmetry or line of symmetry? It's a straight line. Straight line. What this straight line make? It's cut or divide the figure into two congruent parts. It's divide the figure into two congruent parts. That means I can flood into two congruent parts. Look, I can flood these two parts over each other. I can flood these two parts into each other, like the book. If I have here a book like this, okay, and I have here the same. Look. This one, it's called axis of symmetry. Why? Because these two parts of the book, I can flood each other and I can get just one part like each other, exactly like each other. I can cut it from the middle to get two congruent parts like this tree. Here, imagine that you flood here along the dashed line, then the two parts of the figure would exactly match. Both of them have the same figure. Okay. Here in case the dashed line is called a line of symmetry and the figure is called a symmetrical figure in relation to the dashed line, then the two parts of the figure are congruent. So here if I have a line of symmetry, that means these two parts, when I flood each over each other like this, with the first part and the second part, here I flood both of them over each other like the book when you open it and close it. Here that means these two parts are congruent. Look at this remark here. It's not necessary for a line of symmetry dividing a figure into two congruent parts. Okay? It's not necessary for any line dividing a figure into two congruent parts. Because the ABC, this part, when I flood it over ABC, it will be like that. Look, when I flood it, it will be like that. It will not be congruent for the other parts. It it's not be congruent. It will not be axis of symmetry. For example, the diagonal of the parallelogram, like what you watch, ABCD, divide it into two congruent triangles, but it's not a line of symmetry. I can find that both of the two parts are equal, have the same area, have the same border, have the same length, have the same width, all of them, but they are not they are congruent, but this line is not axis of symmetry, or it's not line of symmetry. It comes as a complete diagonal of the parallelogram, or we can put for you rectangle because they have the same shape. Not exactly the same shape, but like each other. A diagonal of rectangle divides it into two congruent triangles, but it's not line of symmetry for the rectangle. Okay? They have the same question. It comes in exam as a complete. A diagonal of rectangle, divide it into two dots, and you will write congruent triangles. But it's not a line of dot for the rectangle. You will write not a line of symmetry. Okay? Here we have some figures. It has number of line of symmetry. Like what? Like the equilateral triangle. Here in the equilateral triangle, for the first one, it has three axes of symmetry. Three axes of symmetry. Here you must keep all of these numbers because it comes in the exam as a complete. He will write for you the equilateral triangle has dot axis of symmetry. You will write 3. And here the isosceles triangle has how many axes of symmetry? Any isosceles at just one axis of symmetry. So here the isosceles triangle has one axis of symmetry. And here the 7 has 0 axis of symmetry because here I can't divide it into two congruent parts. Okay? The parallelogram also has 0. Rhombus has 2 axes of symmetry. Look, they make here perpendicular. Here 2. The rectangle also has 2. Here. And then here I have the square. It has 4 axes of symmetry. Regular hexagon will take before the hexagon, pentagon, and so on. With the regular hexagon has 6. Trapezium 0. And here isosceles trapezium. I said before any isosceles, when you see isosceles, you will write 1. Isosceles triangle or isosceles trapezium, you will write 1. You must keep all of these numbers. Again, here the equilateral triangle 3, isosceles triangle any isosceles 1, scalar triangle 0, parallelogram 0, rhombus 2, rectangle 2, square 4, regular hexagon 6, trapezium 0, and isosceles trapezium 1. And we have more of these figures like the pentagon. We take before pentagon. The pentagon has 5 axes of symmetry. Okay, pentagon 5, hexagon 6, heptagon 7. Heptagon has 7 axes. Octagon, we take before octagon. Octagon has how many axes? 8 axes of symmetry. And the last one he will ask about the circle. Okay, if I have a circle and I need to cut it into two congruent parts, look, I can make it like this, and also like this, and like this, and like this. All of them make the two parts congruent. So the circle has many axes of symmetry. Many axes of symmetry. Or we can write it a lot of axes of symmetry. Or we will write here the exact answer: infinite axis of symmetry. Infinite axis of symmetry. Here is the correct answer. Okay? So the circle we can write many axes of symmetry, a lot of axes of symmetry, but the exact answer we will write infinite axis of symmetry. Okay? Because it comes as a complete. Let's now solve the complete. The isosceles triangle has how many lines of symmetry? We said before, any isosceles has 1. Any isosceles has 1. Equilateral triangle has 3 lines of symmetry. Isosceles trapezium, again, any isosceles has 1, square has 4, square has 4, rectangle and rhombus has 2, again, isosceles triangle, isosceles trapezium 1, any isosceles has 1, equilateral triangle 3, square 4, rectangle and rhombus 2, regular pentagon 5, regular pentagon 5, regular hexagon 6, and regular heptagon, yes, it's 7, regular octagon 8, the circle infinite. Look at the last one, the most important one, a diagonal of rectangle. Look, we'll change parallelogram into rectangle. Here a diagonal of rectangle divided into two congruent words, but it's not axis of symmetry. It's not axis of symmetry. Axis of symmetry. Okay? Let's solve some questions like MN equal to dot, OB equal to dot, measure of angle NOB equal to measure of angle dot. Here MN, look, when I plot here both of the two triangles, MN, when I plot it down, when I plot this triangle down over NOB, here I can find that MN congruent to NO, the same. OB, this one, when I plot it up, it will be congruent to equal to BN. Then measure of angle NOB, it will be congruent to what? To NB, the same. Okay, in order. Let's solve the last question here in the opposite figure. The dashed line is a line of symmetry complete. XY. When I fly it to the right side, I can find that XY equal to XQ. That's right. Okay, QB. Congruent to what? That's right. YZ. Okay, ZT, this line will be congruent to what? That's right, ZB. Let's take the angle XYZ. Okay, let's here and let's try again. The angle is equal to XYZ. I need the same on the other side. It will be XQB. In order. Okay. QBT. It will be congruent to the other side like what? Like YZT. Okay, the last one, ZDX. Take care from this one. ZDX. Look in the order. ZT and go up X. So here the same. It will be congruent to what? BTX. That's right. Is it clear? Okay, try it by yourself and you try to solve all of this question before you solve the answers.